This is section 10.5 on solving rational equations. So rational equations are different than rational expressions. Rational equations have an equal sign already built into the problem. You will see an equal sign at the beginning of the problem. Expressions have no equal sign. Section 10.1, 10.2, and 10.3, all the notes up to this point, we've only been looking at expressions. Now we're going to apply everything we've learned in those three sections to equations, and it makes equations a little bit easier to work with now that we've covered all the basics of rational expressions. So to solve a rational equation, the first thing you want to do is look for and state any restrictions on the domain, like we talked about in 10.1. Remember that means that the denominator cannot equal 0. So that should be easy to spot, and we can write those down before we start. Then you want to make common denominators for all terms on both sides of the equation. Step 1 is going to be the most challenging part. Sometimes that involves factoring. Making those common denominators can be a little tricky. That's what we learned how to do in section 10.2. Then you ignore all your denominators. That's the best part about equations. And it's only true for equation solving, not simplifying. A lot of students get that mixed up now that we've learned both. So it's only true for equation solving that you can ignore all the denominators. Then you solve for the variable, and you're either going to have a linear equation to solve or a quadratic equation to solve, and we'll see a little bit of both in these examples. So we'll start with a simple one. We have 4x over 5 plus 3 over 2 equals 3x over 10. I did forget to mention you might want some scratch paper here. I tried to give you space, but these do get pretty involved. So you might want some scratch paper ready just in case. This first one we should be good. So the first thing we want to look for are restrictions, and that's only true if there is a variable on the denominator. For this first one, there is no variable on the denominator, so there are no restrictions. For example, number 1. So then we look at our denominators and we make common denominators. I chose this one because it's nice and simple, just with values. We have 5, 2, and 10. So we're going to multiply the first fraction by 2 and the second fraction by 5, so that all the denominators will be 10. So what we have is, we're going to multiply this out and this out. 8x over 10 plus 15 over 10 equals 3x over 10. Given all of the denominators are now 10 on both sides of the equation, we can ignore those denominators. And that gives us a simple equation to solve. 8x plus 15 equals 3x. We'll move the 8x to the other side. And I'm going to work sideways here. 15 equals negative 5x. Divide by negative 5, and x equals negative 3. Because there were no restrictions, that is a valid answer. If there are restrictions, once we get our answers, we have to go back and double check that they are not one of their restrictions, and we'll see that a couple times as we go along. Alright, let's look at example 2. We have 3 over x minus x plus 21 over 3x equals 5 over 3. So we have x, 3x, and 3 on the denominator, which means we are going to have a restriction. X cannot equal 0 is one of our restrictions, and 3x cannot equal 0, which if we were to solve that, you can't see what I'm doing, if we were to solve that, it would still be x cannot equal 0. So that is our restriction, which means once we're done solving, if this is one of our answers, it does not work. After we get our restrictions done, then we look and make common denominators. The first fraction needs a 3. The second fraction is good. And the third fraction needs an x. So all the denominators need to match. Another thing to be careful about here is we are subtracting, which means this binomial is going to get affected by that subtraction. We'll deal with that here in just a second. Alright, so multiplying out the top, so we have 9 over 3x minus, I'm going to put that in parentheses, x plus 21 over 3x equals 5x over 3x. Now that they're all divided by 3x, we can ignore the denominators. That gives us the equation 9 minus, I'm going to distribute that negative to negative x minus 21 equals 5x. I'm going to put the 9 with the minus 21 to get negative 12 minus x equals 5x. I'm going to add x to both sides, just some simple linear solving here. I'm going to work sideways. You should get negative 12 equals 6x, which means x equals negative 2. So because that's not one of our restrictions, that is a valid answer. If you'd like to try example 3, you can, or you can just watch me. These get pretty complicated pretty quickly, so you might want to follow along with all of these. But at any time, you're always welcome to pause the video and try on your own. So let's look at the restrictions first. We know 2x minus 1, let me draw a line so we can follow it. 2x minus 1 cannot equal 0, which means that x cannot equal 1/2, and x cannot equal 0. So this is one restriction, and that's another. So I'm going to work this on my scratch paper so I have more space. I have 2x over 2x minus 1. Plus, I'm going to give myself a little bit of space here before I write 1 over x equals 1 over 2x minus 1. So we have 2x minus 1, just x, and 2x minus 1 again. So the first fraction needs x. The middle fraction needs 2x minus 1. And the third fraction needs x. And again, that can get pretty involved. Just make sure you can see that every fraction now has x, and every fraction has 2x minus 1. So then we're going to multiply that, and multiply that. Because all the denominators now match, you can from here ignore the denominators instead of rewriting them all again and then ignoring them. So you can do a visual check right here and make sure that they all match, and then you can ignore them. So pulling that back out, you should get 2x squared plus, that would just be 2x minus 1 equals, that should be x. Anytime you have a squared component, that means you're going to have to factor, which means you're going to have a quadratic. When you have to factor, you need to move all terms to one side. We haven't really seen this much. We'll see it more in chapter 12 and maybe a little bit in chapter 11. But anytime you have a squared term, you want to, instead of balancing like we do for linear, we want to move everything to one side. So I'm going to move that x to the other side. That's going to give me, I'm going to work sideways here, 2x squared plus x minus 1 equals 0. Once it equals 0, then we're going to factor. Okay, I'm just going to factor this real quick. 1 and 1. That will be plus and that will be minus. So you want to get that thing factored. Still equals 0, and once you have it factored, you end up with two answers. I'm sorry I did not give you guys enough space here. 2x minus 1 equals 0, or x plus 1 equals 0. So your first answer is x equals 1/2, and your second answer is x equals -1. if we go back and look at our restrictions, we'll see that 1/2 was a restriction, which means if I plug in 1/2, I'm going to get 0 for a denominator, and that's no good. So that's not a good answer. We won't even put that in my math lab at all. So the only valid answer is x equals -1. So even though it was quadratic, we got 2 answers. Because 1/2 is a restriction, we're not going to use that answer. Alright, we'll do some more of those here in a few minutes. Let's look at one that's a little bit simpler. That one got pretty complicated pretty quickly. Alright, let's look at example 4. We only have integers on the denominator, so there are no restrictions. You always want to do that first so you don't forget. I'm going to put this 12 over 1 so that we have numerators and denominators for everybody. Because all the denominators are integers, it makes it a little bit easier. This is going to be multiplied by 3. This will be multiplied by 2. That'll be multiplied by 6. A lot of students forget about the one that's all by itself, especially when it's an integer. So make a special note that the term by itself also needs that common denominator. So we're going to distribute that 3. That should give us 3x plus 3 minus 2 times x is 2x equals 12 times 6, which, let me just make sure, I'm pretty sure it's 72. Yep. And because I know this is going to be 6, 6, and 6, I can ignore those. And then solve, that'll be x plus 3 equals 72. And you'll get your final answer. And because there was no restrictions, we are just done. X equals 69. Alright, I'm just going to keep working these. They do get pretty complicated. I might stop and make a second video just so you're not too bombarded all in one video. It's good to take breaks. Alright, let's look at example 5. We have x minus 3, x squared minus 9, and x plus 3. Anytime we have a squared term, we're going to have to factor. This is a nice simple difference of squares. So the factors into x plus 3 and x minus 3. So my restrictions, x minus 3 cannot equal 0, so x cannot equal positive 3. And the other restriction is x plus 3 cannot equal 0, so x cannot equal negative 3. So as we go along, and as long as we don't get those two answers, we are good to go. I'm going to rewrite it on a separate sheet of paper so I have more space. 2x over x minus 3 plus 6 minus 2x over x plus 3x minus 3 equals x over x plus 3. I did not give myself space around the middle term this time because it already has both components. And usually you want to give yourself space just in case you're missing something. So this makes it clear to see that the first term is missing x plus 3 and that the last term over here by itself is missing x minus 3. Once you're visually sure that they all have common denominators, they all have x plus 3, they all have x minus 3, then you can ignore the denominator. We're going to have a little bit of work to do up top. We're going to have to distribute that. That's going to give us 2x squared plus 6x plus, this just stays the same, 6 minus 2x equals x times x is x squared minus 3x. So it's a little complicated there. I see some squared terms, so I want to get everything to one side, and I can also combine like terms as I go along. So we have 2x squared plus 4x plus 6 equals x squared minus 3x. I'm going to move both of those terms to the left. I'm going to add 3x and subtract x squared. That's going to give me x squared plus 7x plus 6 equals 0. Once it equals 0, you know that you can factor. So you have to get everything to one side and then factor. From here, it factors into x plus 1 and x plus 6, and they both equal 0, so you have two answers. X plus 1 equals 0, and x plus 6 equals 0. So two answers are x equals -1, x equals -6. We're going to go back and check our restrictions. So I'm going to write those up here. If we check my restrictions, it was 3 and -3. So -1 and -6 are both valid. So I want to make sure they're not restrictions. So this can evolve very quickly. It can turn into a quadratic at any time. When it becomes a quadratic, you start to clean it up, move everything to one side, get it set equal to 0. Then you can factor, then set each binomial equal to 0 to get your answers. And finally, double check that your answers are not restrictions. Let's try another one. Very similar. If you want to try this on your own, I do encourage you to pause the video and give it a try. After this one, I think I'm going to break and I'll save the last two for a separate short video. Alright, so for example 6, we have x minus 2, x squared minus 4, and x plus 2. So my restrictions are that x cannot equal positive 2 and x cannot equal -2. The middle denominator factors into x plus 2 and x minus 2, which means the first term needs x plus 2 and the last term needs x minus 2. The other part of this problem you have to be careful about is the subtraction here. It applies to both pieces on this numerator, so it's going to distribute. Be careful there. So once I multiply all that on, I'm going to ignore the denominator and clean this up. That might have gotten a little too messy there. So we should have 2x plus 4 minus 5 minus 2x, because of this subtraction, equals x squared minus 2x. So that's already ignoring the denominator, getting the top all cleaned up. When I see x squared, I like to move everything to that side. You want to leave your x squared term positive. So we have positive 2x here, negative 2x here. Those zero out. Positive 4 minus 5 is minus 1. So we have -1 equals x squared minus 2x. Go ahead and move that 1 to the right. So you should have 0 equals x squared minus 2x plus 1. From there we want to factor. And that factors into x minus 1 times x minus 1. Just the same binomial twice, so you really just have one answer. Still equals 0. So you really just have one answer, x minus 1 equals 0, so x equals positive 1. And we go back, make sure it's not one of the restrictions, which it is not. So the answer there is x equals positive 1. I'm going to stop there and I'll record the last two examples in a second short video.